Okay, hi Miss Twain, this is Marisa. I'm doing the log video retake. First I'll be talking about log properties and rules. So number one is log base m equals x. So first we take b and move it around like it's giving x a hug. Then we change it to b of x equals m. An example would be log of 340 equals x. Take this, move it over here. So then it would turn into 3x equals 40. Number 2 is log b m power of n. So you would take n and you'd move it to the front of the equation. Oops. Like so. So it would be n log b m. So an example would be log of 4 to x. And you take this x and you'd move it in front. So it would be x log 4 2. Erase this. Okay. Number 3 is log of base b x equals log b y. So because log of b equals to log of b, it would be crossing these out, they cancel each other out, and it would just be x equals y. An example of that would be, say, log of 4, say 2 equals log of 4 3. So it would be cross these out, 2 equals 3, which makes no sense, but whatever. So 4 is log of base b m, and n equals what? So for this one, so we want to separate m from n. Oops. So you would have to do log of b m plus log b n. So with multiplication, it would be addition. So then the same goes for number 5. So 5 is log b, and then m over n equals what? So for this one, instead of, since it's division, you would do subtraction. So it would be log b m minus log b n. An example of the first one could be log of 2, say 12 and 4, and then you would separate them, log 2, 12 plus log 2, 4, and then you would solve from there. For this one, it could be the same thing, like log of 2 is 12 over 4. You expand it to be log 2, 12 minus log 2, 4. Number 6, log base b, and n. So this would be the same as the third rule. And you would move, or you would cross out log of b because the bases are the same, so just equal to m. So it's an example, log of 3, and then exponent of x. So these are the same, so just equal x. Number 7, a log a b. Oh, whoops, I did it wrong. Log a b. There we go. Okay. This rule also applies with rule 3 or in rule 6. So because these two bases are the same, they cross out and it'll just be b. Example would be e, and it's a natural log of 2. Because natural log's base is also e, it would cross out and just equal 2. So those were the rules. Now change of base. Formula. So it would be log a b would equal to log b over log a. So this applies to a lot of the equations that we do. An example would be log 4, 6, and then you would make that into log 6 over log 4, And you would solve for that using a calculator, and that would be 1.29. Okay, so now for the problems. Number 1 is the natural log base of e of x equals 12. So you take e, wrap it around, it would be e 12 equals x. Number 2, log base 7 18 equals x. It would be same thing, the change of base formula, which would be log 18 over log of 7. You calculate that in your calculator, that's 1.48. Number 3 is log 10 9/17. So because log's base is already 10, they're the same, they cross out, it would just be 9/17. Number 4 is e to natural log 62. Same thing, this is base e, they cross out, just equals 62. Number 5, log base 3, 54 minus log 3, 2 equals x. So for this one's subtraction. So this would be using division. So because these are the same, you can have 1. It would be log base 3, then 54 over 2. And calculate that out, and that equals 3. Oops, that equals 3, not 2. 3. So that's the first 5. And by the way, I am using a sock. I couldn't find an eraser. I'll just watch it later. Okay, so for the next 5, number 6, 2 log of 5 and 10 plus 2 log 5, 25 equals x. So this one's addition. So this one would be multiplication. So you multiply these two together. So it would be 2 log 5, 250 equals x. You calculate this out in the calculator, and that would equal to 6.86. Number 7, log of base 4 x plus log 4 x minus 5 equals log 4 and 14. So for this one, do the same thing. So log 4 equals to x squared minus 5x equals log 4 14. Because these are the same, they x out. So you're left with x squared minus 5x equals 14. Oops. So for this one, you equal it to 0.